Today we're going to talk about buoyancy. And this is a very interesting topic because we ask questions like, why does a ship that's made out of steel floats on the surface of the sea while just a small nail sinks? And this question will be answered today. So let's suppose that we have a beaker, and this beaker contains a liquid like this. So all of this is a liquid here, and we put an object inside the liquid. So what happens is, according to Newton's law, for every action there is a reaction which is equal in magnitude and opposite in direction. So the liquid will act in an opposite direction. So if the object acts with a force, then the liquid will act with a negative force, equal in magnitude and obviously opposite in direction. And we can calculate this force by supposing that the liquid itself is the object that we're dealing with. So we will take a part of this liquid and assume that it is the object that we dropped into the liquid. So we'll take a cylinder like this of the same liquid and see the forces that act on this cylinder of liquid. We will see forces from the sides, but these ones will cancel each other because they are opposite in direction. But the upper force and the lower force will not cancel each other because here we also have the atmospheric pressure. So actually they're not completely equal and they will not cancel each other. So these forces will be calculated, and this is how we calculate the buoyancy. This is how we determine if an object is gonna sink or float or stay suspended in the liquid. So let's say this height until here is called h1, and the height of the object is called h2. So this is the part of the liquid that acts over the object. So h equals h1 minus h2. And in order to calculate the force, we know that the force equals mg, and the mass here equals the volume multiplied by the density multiplied by then multiplied by the gravity. We get the force. And as the two objects are made of the same material, we're dealing with the same liquid here, so the forces or the densities will be the same. And also the volume is made of the area multiplied by the height. So this also equals the force. So the constants here are the area, the density, and the gravity. Here is the only variant. So h equals h1 minus h2. So the force will equal the area multiplied by the density multiplied by the gravity and multiplied by the height difference. Now, this is the force that acts on the object inside the cylinder or inside the liquid. Now, how can we determine if the object inside is gonna sink or float or be suspended in the liquid. If the object floats, this means that it's less dense than the liquid. So the force of buoyancy will equal the density of the liquid minus the density of the solid object, and then multiplied by the volume and the gravity. So if the object floats, this means that the density of the object is less than the density of the liquid. So when we subtract them from each other, we get a positive value, and this means that the force that's acting on the object is higher. So the density here will give a positive value, and we get a positive response. So the direction of the force will be in favor of the action of the liquid, and it goes upwards like this, and the object goes upwards and floats. If they're equal to each other, we get a zero here, and the object will be suspended in the liquid. Doesn't float and doesn't sink either. If the density of the object is higher than the density of the liquid, we'll get a negative value, and the action will not be in the favor of the reaction of the liquid, and on the other hand, it will be in favor of the action of the object itself being thrown into the liquid, so it will continue going downwards and it will sink. This is how we calculate buoyancy. A final thing is that if we have an object which is suspended with a string in a liquid, regardless of its weight or density, or a spring like that, is suspended in the liquid, so it's prevented from sinking or floating, we can calculate something called the apparent weight. The apparent weight of the object. So this is not really the weight of the object, but this is the weight that we see if something like this happens, and this weight can be calculated with an opposite rule to the rule of buoyancy. So instead of saying F buoyancy equals the density of the liquid minus the density of the object or the solid multiplied by the volume and the gravity, we flip these ones, so we have the density of the solid minus the density of the liquid multiplied by the volume and the gravity. And of course this will be the apparent weight of the object. So this is why when we drop a nail, a metal nail, in a box of a liquid, it sinks because the amount of force that opposes the weight of the nail is very, very small, and it's not able to act in an opposite direction to lift it up and make it float. On the other hand, for a very large ship made of steel that sails into the sea, it replaces an amount of water which is enough to produce a force that's able to act in an opposite direction and lift the ship and make it float on the surface. So it all depends on the amount of replaced water and its density and its generated force that allows buoyancy to happen or occur or not. So this is it for today. I hope it was clear for you, and until the next time, I thank you for watching and see you.